go here. Okay. Seems like we're good. Okay, good morning, everyone. Thank you so much for joining me and us, AI for People, this morning on a hot Sunday morning. Well, first of all, I would like to thank you for being here as myself, as AI for People. Second of all, a little bit of housekeeping. So this lecture is long. It's a workshop. It's going to be 3 hours. This means that even though long, I would like to keep up your attention. I know we have a break in the middle after 1 hour 30, and that will be a 30 minutes break. But what I would like to do is to just start off for maybe 40 or 50 minutes, and then at a point, I will stop for questions. In this way, we will have a little, let's say, not really an official break, but a way to chat more with each other, and it will not be just a frontal lecture. Having said that, at any point, please post questions in the chat. I think that would be nice. Also, you will see that during my presentation already, as I start, I will ask questions to you. So within this format, I just ask you to be active in the chat. You will have to guess some things. You will have to solve some exercises. Nothing too big, no worries. Nothing that requires too much of your energy, especially the initial ones. But please be alert. I'm going to try to wake you up as much as I can. Okay, so let's start. I thought I would just give you a little, I will brief you a bit about my background. Only a couple of minutes. I think it helps to know who is talking. So my name is Marta. I studied philosophy and mathematics for my bachelor. And then I went on to study public policy and philosophy. Even though AI does not appear, let's say, so openly here, it is something that emerged from these various subjects. I took some courses in data mining as I was doing mathematics and some in computer science, and I really started getting interested in the matter, but more from a conceptual standpoint, not necessarily from the coding side. And that's why then I went on to do public policy. Now I'm actually working as an AI policy researcher, apart from also working here in AI for People. So yes, I must say my background is stronger on the AI ethics part than on the technical part. So that's why I'm basically giving this workshop. But yes, I will be happy to reply also to any questions in case related to AI policy. There will be a little bit of that as we go along. And as I said, I decided to found AI for People together with Vincenzo, who will give also a talk later on, Angelo and Giovanni Gaspare, and the whole team is here also, and we've been giving workshops during the day. So yes, we are an association which still, of course, deals with AI, but tries to make sure that AI respects and is catered to the needs of the people. So it starts from the people, from their needs, and it is for them. We are really interdisciplinary. We basically mix within our teams projects that deal with real life AI applications, but we also do a lot of, for example, ethical AI, which comes more from the social science side. So we think about the ethical implications of AI. And we have events such as this, like workshops, we have lectures, we had a coding class thanks to Phil before, we have hackathons, and we like to have discussions being just sharing opinions with people. And we're really open. As you saw, in fact, we shared the Slack link here, as Phil did, to have any of you on our Slack channel. So please feel free to join, introduce yourself. And we have an online meeting once a month. We pull for that in the Slack channel, so it's important to find you there. Mostly, I would like to introduce you. When you think about AI for People, I think something that I must cite is that our action is a bit twofold. We think about it in terms of AI applied to society. So how can we use AI as a technology to solve, hopefully, societal problems? And that's a little bit the part of, let's say, broadly speaking, AI for good. And that's the other side instead, that is society applied to AI, which is, okay, we have society, which is the people. How can we integrate them and their needs without the building and the shaping of AI? And that's also us thinking about ethical implications of AI, or also doing opening events for people to participate and have a say. So that's pretty much it. Now, I wanted to have a little introduction just to give a bit of background about myself. But that's of course not the content for today. So now the real thing starts. Also because I wanted to give you the time to enter this class for who is not a early morning bird. I would like to repeat for those who entered now that I will be speaking, but people from the team, namely Phil, right now, will be taking care of the chat. So feel free to post questions there. And what else? I think we're set. So, as we have 3 hours, I divided it in three main blocks. The first part is really very much an introduction. It's also a bit lighter because you just woke up. But then the second part, the ethical implications one, it's it has a lot of content, and over there I will require your minds to be there very much. But not only your minds, also your chats. And in the end, we're gonna have a case study. Now, I didn't know how much time it would take because the interactive part is a bit uncertain sometimes in terms like to calculate. But I have two case studies. One, I think it's more exciting, so but it's also a bit longer. If we have more time, we're gonna make it. So stop me at any time in case you feel like I'm speaking too fast. Sometimes I tend to do that. I'd like to avoid losing people. Intro. We start with this like really high level introduction of AI. I do that because I think it's important not to tell you what AI is, but in order to see together what we talk about when we're talking about AI, what is entailed in our talks. That's really important for the second part, where we go into the problems or concerns that arise from the use of AI. If we do not know what we talk about when we talk about AI, or what's entailed within the processes, then we cannot really understand, I think, why some problems arise. So let's go for it. It's an exercise. So I would like you to be active in the chat. What is AI and what is not? Okay. So here is the self-driving car. Of course, this is really meant as a game. There's not a perfect answer, and it's just really meant to keep your brain. Okay. So just go for it. It's gone. Oh no. Okay. Can you hear me now? Okay. Okay. Audio is perfect. Okay. It's good that you tell me. Now we can go again. So this is a little game. I'm gonna ask you here, what do you think is AI and what to you is not? There's not a right reply. It's really to wake you up. Okay. So self-driving car versus Facebook feed. I'm gonna check the chat, huh? You can also say both. You can also motivate your answer. I see I gave something away. I see someone said car. Many saying both. Okay, right. I mean, it's true, it's both. There is a component in both of them, definitely, which we're gonna see. Then we're gonna see, okay, algorithm versus equation. Open question again. This is more philosophical than anything, huh? I see people are shy now. Depends on their use. Uh-huh. Nice one. None of them. Well, I like the both. Algorithm, like Kevin, a computer scientist. But I mean, yes, there is not, let's say, a correct answer here. But yeah, many of you are correct. Uh, of course, when we talk about algorithms, there's a lot of math involved. There's also a lot of statistics. There are equations. In a way, who knows at what point is an algorithm and when it is a sort of, let's say, equation. Um, Speaking from philosophy, but it's true that Kevin has a point. I mean, surely this equation is not AI, let's say. Okay, but here we go a bit higher level. We have a neural network and really basic here decision tree. Who goes for it? Which one? Or both? Yes. Neural network, I see. Both. Both. Yes, yes, we're going to see the answer to this later on. Okay, so here is all an exercise to say that instead of giving you one definition of AI, I'm going to show you what composes it, what AI is made up of. So it's meant to have components. There are also types of algorithms. They are different. There are types of tasks that an AI can do. And within AI, there is also what we call an AI system lifecycle, which basically makes up the life, or let's say the birth, the life, and the death of an algorithm, if you can say so for an algorithm. So components of AI to begin with. I mean, here it seems like there are two, right? So we go back to our problem and we say, okay, there is a part of the AI which is the computer hardware, which is also largely interchangeable, and that's why this is an explanatory image, but it's more symbolic than anything. I do not mean to say that a self-driving car is a hardware for an AI. It's just really to symbolize that the hardware is the physical component, and the software instead is not the physical component, is basically the portion written by the programmer. And it looks much more like the end result, at least, looks much more like what you have on the right. But is this it to an AI? Is there anything missing, do you think? Anyone for the chat? There is a third component, I think. Environment. Spirit, interesting. Or soul, policy. Ah, because Marcella knows me. That's a description. Okay, I will reveal it. I think there's another part, which is data. Human input. Yeah, in a way, I mean, let's call data human input. Let's say that data is not AI, but when we talk about what composes an AI, I think it does play a big role. So here we have data, hardware, and software. But is that it? So once we have an AI, it's not just we have one AI and that's it. It's just like one big robot that controls us all. There are different types of algorithms that are entailed. Okay, so two examples here, which is something we saw before in the exercise. To go back to it, are neural networks. Versus, let's say, decision tree classifiers. These are already two kinds of algorithm. And while neural networks are algorithms that resemble the biological structure of the brain, namely the interconnection of many neurons, as you can see in the image, even though really not a great image. A decision tree instead is like a simple representation for classifying examples. So it is actually what we call a supervised machine learning task or machine learning algorithm, which is totally different from neural networks. While in supervised machine learning, it is the human who does the labeling of the various features. In neural networks, that's not the case. It's the algorithm that comes up with its own labels. So yes, there are different types of algorithms, and some people might even say, in some cases, maybe, who knows, decision trees do not fall within the AI paradigm. That there are open debates about it, but usually all the time neural networks fall within it. So types of tasks. There are many, many tasks that an AI algorithm engages in. These are really, really, the ones that you see in the image are really easy, the ones I presented. So let's say, what can an AI do? It can classification. It can engage in regression tasks, and that's why regression. Of course, the main difference is that in classification, the decision variable is categorical or discrete, while in regression, the target variable is continuous. So, for example, while you see the regression on the left, that is very much related to weight, which is numbers, right? But that's just really two basic things. We also have what can AI do? Segmentation, network analysis, image recognition, and so on and so forth. So once we have that package and we set that up, we know what an AI can do. We know what types of algorithms are there. I mean, I didn't list them all, also because, and for the sake of time. What we should look into is, I would say, what I call the birth, the life, and the death of an algorithm. Now, this is not an image I like too much, but it is probably the only one that was really representative of the whole cycle. There are many, many different representation of what an AI system life cycle is. And this is just one that I took because I worked with it of the OECD, which basically shows how there is a first part, which is called design, data, and models, which entails, not necessarily in this order, a process of data collection and processing, one of planning and design of the whole AI system, one of model building and interpretation. Of course, this can start, it's not, usually we start from planning and design, right? That's what maybe people would think. But at the same time, sometimes you might just have a bunch of data that you have already collected, right? And after that, you decide and you go into the planning. So, or maybe you start from the planning, then you go with data collection and something goes wrong and you want to plan again. So it really varies. In that sense, it's not a linear order. And then after that's done, we have a phase of verification and validation. And then we deploy the AI system. And at the end of it, we have a phase of operation. We've operated and we keep on monitoring. At any point, whether something goes wrong within the monitoring, this system ought to be open in order to go back at any of the previous stages. You can see that this part, even here, this arrow can even go back at the very beginning or can re-enter at any stage. So it's really very much an open cycle, I would say. I mean, it's closed, but you can re-enter any of the stages before that. Now, this is to have an idea of the complexity behind it, right? It's not just about what happens within an algorithm. It's not just about what happens within the data. Also, at any of these stages, from data collection and processing, from verification and validation to deployment, at any of these stages, something might go wrong. It is really a tough and complex system in that sense. And to give you an overview, because this is more of an industry, I think, standpoint, this AI system lifecycle, but many of you might be in academia, and I think this is how academia sees the AI field. But many of my colleagues are PhDs in AI, so please tell me if you think this representation is wrong. I actually, it's not my representation. I took it from Nicolas Moes, is an AI policy researcher, and I liked how he represented it. So basically, he sees the field of artificial intelligence as coming from what you see at the top: computer science, mathematics, and cognitive science, a mix of all. And maybe people from the social sciences here would disagree. So let me know in the chat if that's the case. And then that forms artificial intelligence, kind of AI is built on the shoulders of those giants. And from that mountain that AI seems to be, what goes downstream? It's subfields such as machine learning, automated reasoning, NLP, computer vision, knowledge representation, robotics, and so on and so forth. And from that subfields, what goes also downstream is, let's say, from machine learning, one application is deep learning. From NLP, we have speech recognition. I like this sort of cascade representation, which kind of gives you an overview of the field in better detail and still high level. So here is what I had to say for AI. I must say I'm not strongly a strongly technical person. So that's also why I do not feel comfortable with going in any more detail in it. But I think I have a responsibility to understand well how these systems work and also how to present it to you. You will see that what we see here is of high relevance for the second part, for the problems and the concerns that come from applying algorithms. So keep this in mind, okay? Ethics. I saw that there are some questions. This is really good. Oh, Marta asked, can you put the slide before when you can? Is it this one? Please, Marta, let me know. The previous one, this one. Perfect. Okay, yes, let me know also if you want to go a bit slower at any point. And I saw there are some questions. So please, of course, Phil will note them down so that whenever we stop, I can reply to them. Probably some, and maybe this one also Phil can reply because he's a cognitive scientist. So that's great. Um, Okay, agenda. So now we switch to the ethics part, okay? I do not know how many of you here have a philosophy background. I know some of you have, but there might also be many technical people. So I will really present some of the main, yeah, I see. So I will present some of the main ethical standpoints, specifically the ones that are relevant to the values that we will see later on, and to the approaches, the so-called ethical approaches that we can take whenever we deal with the problems that we encounter in AI. I will present three main schools, really high level again, okay? So one is virtue ethics, one is deontology, one is consequentialism. So, what are those? Even though AI seems difficult at times, I can say that these names seem even more difficult. Sometimes that's what philosophy does, presents things in a more difficult way than what they might be. But so let me explain you, okay? So virtue ethics is one of the three major approaches in normative ethics. So ethics that is concerned with what behavior or how you should behave, what we should do, the should. It may be identified as one that emphasizes the virtues or moral character. We will see what that means. In contrast with the approach that emphasizes duties and rules. Duties and rules is deontology, okay? I will see why the meaning of that is in the word deontology. Versus what emphasizes the consequences of actions, and this really stays in the name, consequentialism. So a little example, suppose that it's obvious that someone needs to be helped, okay? Now I'll give this away. There will be other examples where you have to reply. But here, just to give you an idea of how each person, either we have a virtue ethicist either we have a deontologist or either we have a consequentialist, how each of them would reason in this situation. So virtue ethicist would just say, oh, it's a good thing to help a person. It's a virtue to be helpful. So that's why I will help this person now in need. Deontology instead would say that doing so, the agent will be acting. So by saving the person, the agent will be acting in accordance with the rule, um, behave towards others as you would behave towards yourself. So it acts out of duty and out of like a moral rule, let's say. And then what would the consequentialist do? Instead, it says, oh, well, saving the person would be exactly what maximizes utility, what would allow me, but also especially the person, to maximize overall well being, let's say. So that's why I will go and save the person. So these are, maybe the outcome is the same, right? They all go and save the person. But at the same time, what changes is why they save the person, the reason behind it. Okay, I see there's already some good discussions. That's great, guys. Keep it up. I really like that we have an active chat. I think it helps a lot. And also, I do not want to be the only one speaking. So when we might even open the floor at some point and have you discuss. But first, I have to give a little bit of theory, right? So I presented the three high level. So virtue ethics. Who is behind virtue ethics? So the main fathers, let's say, of virtue ethics, many people just cited the one in the West. And of course, they are the big elephants in the room, such as Plato and Aristotle. But there is also people in the East, which you might have heard of, such as Confucius, really big name, and Mencius. Here is Mencius, who's represented. I feel like he needed some representation because I'd never heard of him before. I mean, really just a couple of times, while Plato and Aristotle had an intense study of them. So, yes, virtue ethics, these are the founders, let's say. But what are the concepts that are relevant for virtue ethics? So, let's say the first one is arete from Greek, which means excellence or virtue. It is the concept of something that makes its possessor, so whoever has arete, whoever has virtue, who makes its possessor good. So a virtuous person is morally good, is excellent, is an admirable person who acts and feels like they should. Of course, this is a truism, right? It's like stating what makes a person good, just being good by nature, by virtue. But that's how it is defined in virtue ethics. And these are commonly accepted truism within that theory. Is that enough to have virtue? Well, you also have to act according to virtue, right? And that's the second part and the second really important ingredient in virtue ethics, which is phronesis from Greek. Uh, it translates into practical or moral wisdom. And what is that? It's basically a reliance on motivation by inclination. This also sounds really general, right? It means that if you are a virtuous person, let's say you're a honest person, practical wisdom will actually automatically motivate you to act in an honest way by your inclination to be honest. That's again a sort of truism, right? So, within that, a virtuous person almost cannot go wrong, right? By virtue of being honest, it will be inclined to act honestly, and that's practical or moral wisdom. Now, where does this end? Where does this bring us to if we are so virtuous? To eudaimonia. Maybe many of you heard this concept. It is usually translated as happiness or flourishing. And yes, let's say that we might, to bring up all the ingredients, even say that living a life or acting in accordance with virtue is necessary for eudaimonia to reach this sort of higher happiness. This is what virtue ethicists will tell you. I do not know what you think. I'm gonna hear your opinion later on, but before, I think you ought to hear also from the other philosophers. Deontologist, for example. I know the first time I saw this picture, I thought it looked like Mozart, but it's not. It is the infamous or famous Kant, Immanuel Kant. He is one of the main exponents of deontology. And here now I reveal why we call it deontology with this seemingly complicated name. So deon means duty, and that's why we were talking about acting out of duty, and science, or study, let's say, from logos. So to put it together is the study or the science of duty. Kant is one of the main exponents, and we're going to see some of the key concepts that are encapsulated within deontology. So yes, in contemporary moral philosophy, deontology, I would say, is one of those kind of normative theories regarding which choices are morally required or forbidden or either permitted. This is the classification. In other words, it falls within the domain of moral theories that guide actions, and assess our choices of what we ought to do. Okay, but these are in contrast to those instead. Um, no, no, sorry. So the theories that guide and assess our choices of what we ought to do, in contrast to those that guide and assess what kind of persons we are. That's better said. So virtue ethicist would assess you for the kind of person you are, whether you're a virtue, you have virtue, or you have not, whether you are a virtuous person or you are not. What the ontologist instead would assess is your choices, your actions. So that's one of the main differences, and where the shift also happens. Okay, and any system involving a clear set of rules is a form of deontology then. So that's why, in order to make it slightly, no, actually less contemporary than Kant, we could also say that part of deontology might also be the Ten Commandments: do not kill, or the Universal Declaration of Moral Rights, in order to make it a bit more contemporary. Uh, Another really important and famous ingredient in Kant's thought is the categorical imperative. So the categorical imperative, according to Kant, uh, basically it's his insistence on the fact that the maxim or the reasons, and here I need you to follow me, on which one acts be capable of being willed as a universal law, so willed by all rational agents. It sounds complicated, but it's easier than that. It's like act as if when you were acting, anyone would wish that, so your action to be a general rule, a universal law. So basically, a bit like what we said before: do not act, do not do to others what you wouldn't want others to do to yourself, right? Act in accordance to a rule that you wish was a general rule. Well, that sounds high level, yet sounds really interesting. Um, but some people might disagree, right? So deontologies often be seen as strongly opposed to our third main character, consequentialism. Why? This is because in emphasizing this intention to act in accordance with our duties, deontology often believes that the consequences of our action do not really matter. And that's exactly what consequentialists go against. They, by definition, consequentialists think that the ethical part comes and can be assessed through the consequences of our actions, right? Let's say, maybe to give an example, if you were to hide someone, like a friend, in your house, because there are some thieves who are chasing him. This group of thieves comes to your house and is asking you, "Where's your friend?" Um, of course, what is your moral duty now? Do you have a moral duty to not lie or to lie? And in that sense, of course, if like if you act out of duty, we have a duty as a general law not to lie. That's what the categorical imperative would say. That's what Kant would say. But at the same time, in that occasion, you have a friend of yours who is being chased by thieves inside a house. The consequences of you not lying are probably worse than if you break the general law of not lying, right? If you basically tell to the thieves, my friend is in there, they're going to probably take your friend away, do something bad to him. So there are tensions here. There are also logical missteps, and things that have not been like taken care of within some theories, some parts, some fallacies. But of course, each theory feeds into each other. Now I'm going to present you, and I'm presenting you the really, really general terms of them. People have thought about these little glitches for years, and there are answers to many of them. So yes, we saw that consequentialists do not really agree often. Let's see who they are. Consequentialism states that whether an act is morally right depends only on its consequences. Again, I'm presenting one of the extremes, right? There are many less extreme versions of consequentialism. But for the sake of the argument, and also in order to present all the three theories as three different pillars, I'm just going to tell you the most general thing I can tell you about consequentialism. The paradigm case of consequentialism is utilitarianism, which states that, let's say, for what has the highest consequence, what we assess as the biggest consequence, and thus also the most ethical one, the best consequence, let's say, is what brings the maximization of happiness. Happiness, often understood as hedonism, maximization of utility. We will see about that. The founding fathers here are Jeremy Bentham, John Stuart Mill, here on the left in the picture, and Henry Sidgwick. I mean, spell Sidgwick, there is a G missing after the D. That's important. So, consequentialism. We're going, of course, consequentialism is so general that I think what is useful here is focusing on how utilitarianism see consequentialism. Classical utilitarians held hedonistic act consequentialism. What is that, right? So, act consequentialism is the claim that an act is morally right if and only if that act maximizes the good. And until here, we are all okay, right? We said that consequentialism cares about the consequences. We plug in utilitarianism. What we want to maximize is, in its consequences, is the good. But then we plug in also hedonism within the theory of utilitarianism. And this claims that pleasure is the only intrinsic good and that pain is the only intrinsic bad. This means that what are we going to maximize? Pleasure, right? Or in many other versions, it's also called happiness. We might debate about it for a long time. Of course, one of the main sayings that represent utilitarianism is the greatest happiness for the greatest number. I'm sure you've heard it before. So yes, hedonistic act is, oh, can you hear me? No? It's okay. Perfect. It was on his side. Okay, perfect. I tend to move really close to the camera. Now I will just stay here. Uh, thank God I saw the audio. Thank you guys for telling me. Okay, so hedonistic act equals maximization of happiness. Now, a little exercise as the chat got active again. So let's say we have this scenario. Which strand would support the thought, how much evil must we do before doing good? Imagine an old philosopher thinking in his room, realizing that doing good and doing good alone is not that easy. And whenever we try to do good, there is some evil involved in it. Um, Now, who would agree with them? And I'm not saying you now, in order to see whether you really understood the main ingredients of each theory, I would like to ask you, what would a virtue ethicist think of that? Would they agree with this sentence? Like, oh, yeah, we should do evil, or sometimes we must do evil before doing good? I'm going to look at the chat now. No, nope. Let's see. That's totally right. Yes, there's nothing that justifies evil for virtue ethicist. Evil is just not part of virtue, right? You will not even act according to evil as long as you are a good person. Okay, what about deontologists? So when you act out of duty, sometimes might you have a duty to do evil? No, no. Yes. Yes. Yes, and then regret it. Fair. So let's see. No, but I must say, to give credits to the ones in the chat, um, that I was undecided myself. I had seen an example where they said no, and I tend to think it's true that maybe a deontologist would not wish this sentence to be a universal law, um, but maybe this sentence just appears to be a universal law. So there, of course, there's never in doing good. There's never only doing good involved. Sometimes there is some unnecessary and indirect evil involved within that. So yes, no, it's complicated, I would say, for deontologists. Last one on degree of cause. Ah, are you going already? I see Mehraj. Depends on degree of cause might be really relevant for utilitarianism. What do you guys think? Do you think utilitarians will agree with this? Yes. Yes. And that's correct. Yes, exactly. I mean, of course, this is a really general sentence, but let's say that it's to illustrate that they would be fine. They would be fine with evil being there as long as it is there in service of maximizing the good. So I think you all got it. This is good. This means that from here we can proceed to ethics and AI. I mean, I decided to present you first both ingredients separately. So first I presented at a really high level AI, then ethics, namely the part of ethics that will be relevant for our second part. But first, I have two disclaimers. So when we talk about AI ethics, I had many people asking me, okay, you're going to teach a course in AI ethics. What is even that, you know? And it's true that it can appear as a super general statement or field. And people might ask themselves, can AI be ethical? Is that what you're concerned with? That's not our business today. As we will see, that was the concern of people, especially uh, before the first AI winter appeared. So people like Alan Turing, for example, Wiener, who were dealing with AI between the 50s and the 80s, who were dealing with an idea of an AI that was closer to what we call today artificial general intelligence, are more likely to ask themselves this question: can AI be ethical in terms of can it be an ethical agent? I still think these questions are relevant and they're really interesting, but it's not what we will be talking about today. So I'm sorry. But we will actually take it from a human standpoint. We will ask ourselves, can humans engage in AI ethically? That's our business today. Okay, perfect. I would like to stop for a while because we're about to jump in the second main block. So, is there any questions that I can reply, or also any comments, any thoughts? Maybe you guys thought that, like, maybe while you were learning about virtue ethicist, and consequentialist. You saw some parallel between the two or some parallel within your own field. Feel free to flag that out. It would be really interesting to see. We have 3 open questions. Okay. Open questions. What do you mean by open? Okay. Why is that called fourth revolution? Like mechanic? Ooh. Really interesting questions. I hope I'm up to the task. So why AI is called fourth revolution, like mechanical, electrical, and electronics? Um, Yes, it's true. We often refer to AI as the fourth revolution. There is even books written about it. There is Floridi, a big philosopher at the Oxford Internet Institute, who wrote a book even titled "The Fourth Revolution." Thankfully, I happen to have read it, so I can reply to this question, even though I do not have a straightforward one. I think what is currently happening is what, as per what we have documented in the previous revolutions, such as the industrial revolution, the first, the second. It is something that is changing our society in terms of reorganizing, for example, labor, which is also what happened beforehand. It is something which is reorganizing and restructuring knowledge. For example, the way we how can you say that, the way not we perceive but the way we take in information, that is changing. While before it was much less and it was through books, nowadays we are much more exposed to a lot of information. Let's say it is, I think, any revolution that is referred as such, and that maybe where a parallel is with the industrial revolution, let's say, is where our paradigm, so our main fundamental rules of society, being understanding of the world, be it a way in which we organize our society, fundamentally change, given something new, an X that it is introduced in the society. And that X is AI right now. I think, of course, it might be too early to call it a revolution. The first time between the 50s and the 80s when AI appeared, it was probably too early for that. And there were already big talks about we are in a revolution, something big is changing. It might happen again. It might happen that AI is just a bubble. We're researching a lot on it and we just find out it is not up, not to its task, but to the expectations we have built for it. But I do think, in a way, it is called a revolution because we are experiencing, for example, changes in labor. What is the future of work? We are asking ourselves. Changes in the way we educate, especially with coronavirus. The classroom is digital right now. AI is often used to help teachers already in some cases to assess grades or to assess the capacity of the students. It's basically a reorganization of society, I would say. And that's why we're calling it the fourth revolution, I think. Yes, shortly, if you want what I said in 2 lines, it will transform all of our jobs and lives over the next 10 years. Here's a computer scientist, AI PhD, reply. Which, fair enough, to be honest. That's exactly what I said in 2 lines. How do you differentiate ethics and privacy concern in AI? Well, keep tuned for that because it is exactly one of the points in our second part. And I think you, in a way, you don't differentiate. They're deeply linked, ethics and privacy. As you will see, there is a way in which privacy is a value that was there before. We already cared about not sharing our information too much, even in previous eras, but never as relevant as today. It's not that beforehand, when we cared less about privacy, we were just less careful. It was also given the environment and the possibility of what could be done with our data and how much data an institution or just an algorithm could have, was just much less. So let's say that this revolution has made the concept of privacy much relevant for today's world than the world of the past. And that is why I think the concept of privacy has been entangled with the one of ethics. It's not just about a technical concept of not giving access or to data of someone. It is much deeper than that. It's if I have access to this data, what can I do with it? That part can have ethical consequences, and that is where they're tied. I do not know whether that fully answers the question, but there will be a specific point on it in problems and values. So keep tuned. Uh, Last one. Oh, thank you for actually sharing the book, The Fourth Revolution. Thank you, Antoinette. That's great. From a post-colonial perspective, I wonder if the AI ethics you are presenting is only looking at the Western philosophical tradition. That is also totally correct. So we are going to have a talk about colonial AI later on today, which I think is really important. On one hand, my main field of study, it's AI policy, which already takes up ethical values that are presented in many AI guidelines, that being privacy, that being fairness, bias. These are concepts that, as I will show in the next slides, are deeply tied in the Western tradition and in the Western way of dealing also with concepts. Um, Nonetheless, these values are, first of all, seen differently in, let's say, China, Japan. The concept of privacy in Japan and in China is not valued in the same way as it is in our society. And these other societies might just have totally different concepts and totally different values. So that is what I am not presenting today. I'm sorry about that. It's very much because I do not know enough of the other field. I couldn't give a lecture on that. But I hope Maurice in the next class, who will do his PhD on that, will be able to cater for that. So yes, but I will, as I go ahead, really let you know about the fact and about the limitations of what I'm presenting. I'm really aware that many things I'm presenting are Western centric, and that's also problematic. Okay, so I think we should go ahead. Otherwise, we will not get the case study. I thank you very much for your questions. Also, my answers are not surely totally exhaustive. So if any of the participants thinks, I might have a better answer for that, please engage with people in the audience. I've been in other lectures where people have started replying their own questions, and that led to really interesting discussions. And so yes, feel free also to share books. Thank you for doing that, Antoinette. Really, really nice. So let's go. Are you ready for ethical implications? This one requires a lot of brain power. It's quite some content and is the core of the talk. So get ready. Ethical implications. So I presented before the life cycle, right, of an AI. Now, I would like to present that in a much easier way, in what I would call a prose version, in a few lines, which are really synthetic, but that would be really helpful in, let's say, listing the main ingredients where we need to focus on in order to check what concerns are there in matters of AI. So, first line of our poem, not of our prose, is algorithms turn data into evidence for a given outcome. Okay, hope we all agree. Second step, this outcome is used to trigger and motivate an action. Okay, so it doesn't stop at a theoretical endeavor. We go into action. And action may not be ethically neutral. This is not to ascribe any intention to the AI, and sometimes not even to the human behind it, but on a higher degree. Sometimes the action, whatever it may be, whatever the intention behind it is, may not be ethically neutral in its consequences. We'll see about this line as well, what comes with it. Final ingredient, and an algorithm works in complex and autonomous or semi-autonomous ways. All these characteristics that make up what an algorithm does at different stages might generate different concerns. Okay, and later on, I call them problems. I do not know. Maybe concerns would have been a better word, but I should think about it for next time. Okay, so here we go. This prose generates the need for, I mean, we saw that several parts in this text might generate concerns, problems, right? We'll see, I'll contextualize that better later on. This generates problems. How do we respond to problems? With values. And this will be that, what you will see that virtue ethics will play a role in there. And then how do we act from values? Actions. And our ethical framework, one of them we will see, will also play a big role in saying how should we act once we think we know what is right and what is wrong, if we ever get to know that. Okay, so remember the structure. Here is how we're going to go about it in this section. First, I'm going to present you really briefly what is usually meant by ethical AI, a bit similar to the disclaimer I did before. Then we go into the problems and challenges related to algorithms, which is the first part before the arrow, problems. Then values, what is the most ethical approach, and actions. Is there a lawful approach? We'll also see that in terms of actions, I'm going to try to cover a bit also the technical side of actions. What can people with a technical background do in order to tackle concerns? I will just present a mapping of that, however. Not being a technical person, I'm just going to, like, how can I say, put forward knowledge for them to act on it, hopefully. Okay, so ethical AI. The debate about ethical implications on AI dates from the 1960s, let's say between 50s and 80s, at the time of Samuel Wiener and Turing. Alan Turing, I'm positive most of you know him or heard of him. Of course, big elephant in the room here is the Alan Turing test, where there is ideally a judge and there is a human, there is a computer. Computer has to fool the judge into believing that he is the human. And if he makes it, then we can say, that computer is intelligent in a human understanding of intelligence. Of course, you might just say, and I will look at the chat here, oh, maybe that computer is just behaving as if it was intelligent, or it was intelligent. That was the debate at the time, much more related to what we said before, artificial general intelligence. And in that sense, the questions of ethics that were coming were much more existentially related to what is an AI? Can an AI be a moral agent? Then what happened? In the 1980s, the AI winter came. Research was not getting anywhere, and there was, let's say, a freezing of the field. And at that point, this sort of talks about that had started about ethical AI stopped as well. It all came back with what's happening today in the fourth revolution, as you said, that we are living, where what has changed is basically mainly a shift from symbolic systems to what we refer today as like deep neural networks and machine learning. Symbolic systems, what are those? So in between the 50s and the 80s, most of the work that was going into algorithms was based on symbolic systems. Also referred to as like high level symbolic, meaning human readable representations of problems, often in logic forms. So an algorithm in that sense would have been a set of fixed rules or even logical predicates from which the algorithm could just deduce the next step. Of course, in that sense, where we started using and wanting to use algorithms in order to predict things, what you do with prediction is nothing related to deduction, but is like inducing things, right? So we had a shift, and that was the new breakthrough with neural networks and machine learning, which are not rule-based systems, but instead, maybe coarsely said, they come up with their own rules. So totally change within the field. We're basing the field mostly, even though still rule-based systems are there, and much of the work being done is on expert systems, which are rule-based. So this is a disclaimer. It's not that it's like a shift that happened overnight. and we're only talking about neural networks today, even though part part of that is true. But that is mostly the juice of what has changed, let's say. In order to put it in the context of ethical AI, I think we should consider this important sentence from researchers Anani and Crawford, which said, ML algorithms are powerful social technical constructs. So that has also changed. Before, algorithms used to be considered from what they were often, which is like technical constructs, code. But today, we are more and more aware that algorithms raise concern about people as much as about code. Why is that so? Well, partly because, as we saw in the AI lifecycle, people are behind the code being done, not all the time, but sometimes, or at least every time at some stage. But at the same time, even though there's no one ill intentioned behind the building of an AI, often, as we saw in our prose recipe, the actions that derive from it might just be not ethically neutral in their effects because they affect people's lives. And in that sense, that is why when we talk about ML algorithms, we can really talk about constructs that affect also the life of people and as such raise concerns about people as well as code. Um, why did I put ethical, robust, and lawful down there? Because often when we talk about ethical AI, we just think we should refer to the ethical part of it. But ethics does not end where the field ends. Sometimes we can also see it as transversal, and the European Commission has done a lot of work on that and defines in its ethical guidelines on AI something called as ethical AI as something that is ethical, but also robust and lawful, so law abiding. We will see also later on what that means. But I'm building little blocks here to get you ready for what comes. So remember these little blocks. What are the problems and challenges? Okay. So we go back to our recipe and we said algorithms turn data into evidence for a given outcome. Okay. This outcome is used to trigger and motivate an action. What could be a concern there? Maybe it's too much to ask you to come up with a concern, because here the concerns could be many. But maybe I would like to have a round in the chat of what do you think could go wrong in there. So we have data, we need to turn it into evidence in order to justify an action. What might be the problems? And I'm turning to the chat. And of course, we have people coming from the technical field, we have people coming from the social science, we have humanities. So really shoot. Let's see. Goodwill or evil will. Yes, that's true. That's definitely true. Outcome and action. Mm-hmm. Anyone else? Wrong or tainted data. Yeah, really good. Exactly, from a technical standpoint, and not only technical. Bias. Yes, we're going to deal with that, as you will see later on. Our case study is based on bias. Wrong or tainted. Accountability. Big one also for our case study. Really important. Anything else? Okay. Oh no, can you hear me now? Audio is gone. Yeah. Unless you use it to shoot the object. Marcello is there. Oh, good, it's there. I can hear you. Okay, I feel we have several opinions in the chat, which might do for a good discussion. First, I will go ahead taking in what you said and your suggestions. Even before going into thoughts like, okay, accountability, bias, this will be the sort of values, let's say, not bias, but freedom from bias, that we will use to reply to these concerns that are arising. First, I'm going to present a first concern that might arise: inconclusive evidence. What is that? Now you will see a detective here. Um, I would like to present you the whole series of concerns that happen within the working of an algorithms and during the workings of an algorithms, as if it was a detective story. Okay, I will always refer back to algorithms, but let's think about it in terms of we are a detective. We have to solve a case, so we need to turn data that we receive, right, into evidence, just like an algorithm needs to do, or a human who works with an algorithm needs to do, in a way that we need. So we need to turn this data into evidence to motivate our actions or to trigger our actions, right, to solve our case. Okay. So all that you said before, accountability, we need to be accountable to the population when we solve the case, to the people involved. Bias, we should really be careful not to be biased, and humans are really biased. That's also our detective. So let's keep in mind the idea of a detective here. So inconclusive evidence, what would that amount to? If you're a detective and let's say you are looking into solving your case, unless you have an infallible proof and you caught someone on the scene, you will most probably have to work with probabilities. You will have suspects, a series of them, and you will think, oh, maybe there is like 80% probability that the baker is has committed the crime. Oh, but maybe I also think 30% the doctor. So it's never, your judgment will never be infallible and certain in that way. That's also how algorithms need to work, in the sense of, especially when you talk about machine learning, these are statistical systems, right? They're based on probabilities. This raises 2 points. The knowledge that comes out of that, it's probable, yet inevitably uncertain. Level of certainty can even reach 99%. But correct me if I'm wrong, I think it's tough to say that we'll ever have 100% certainty from arising from an algorithm. So we really need to deal with uncertainty, which is a natural fact of probability. And apart from that, there is another ingredient that adds to the picture, which is correlation versus causality. So statistical methods can help identify correlations, but these are really rarely considered to be sufficient as well to posit the existence of a causal connection. Of course, you can assess a causal connection, but then you will need a proper causal inference test for that. That's expensive. That's not all the time the only answer. So often we have to deal with data to turn into evidence that yet are not, we cannot fully justify in terms of not being fully certain of their grounds, and neither of their causal import. How do we deal with that? Well, in terms of an algorithm, you just have to deal with it. We will have to delve into actions, not being certain of what we're doing. So risk management is a big, and I think it will be a big field in the future in when we're talking about algorithms. An example is, for example, an algorithm used to predict the risk of art failure. Algorithms are never, as we said, 100% accurate. So in case the algorithm has an accuracy of, let's say, 85%, 15 patients out of 100 will be incorrectly diagnosed. Now, the question is not, is it fair? Is it not fair? Just simply, is this level of certainty enough to justify an action? So to follow up with a test or to bring that AI into production. These are concerns. We go back, and if some of you have like some thoughts triggered during this as we go along, please write them in the chat. Okay. I will look into that. Okay. Second concern. So we go back to the recipe. Algorithms turn data into evidence for a given outcome. Outcome used to trigger and motivate an action. What could go wrong once again, or what could be a concern? Inscrutable evidence. What is that? I wanted to represent it with like this crystal ball. So we have our detective is trying to find out and to discover the case. And let's say he thinks he knows who he is, maybe even saw the guy committing the crime, but he was the only witness, right? The detective was the only witness. He doesn't know how, maybe he just saw the criminal getting out of the house. He doesn't know how the criminal did it, how he committed the crime. He doesn't know how to justify it to the public. How will I say, I think it's Bob, but I do not know how Bob did the crime and I do not have any proof, right? So, in order to turn data into evidence and to justify action, you need to have some ingredients that you can bring up to the public and also to yourself in order to justify the conclusion you have reached, right? Um, and within, to put this within an algorithmic context, when data are used or processed to produce evidence for a conclusion, it is reasonable actually to expect that the connection between the data and the conclusion should be accessible. When the connection between those is not obvious, this expectation can be satisfied by better access to explanation, but as well as by additional explanations often. Given how algorithms operate, these requirements are not always satisfied. We will see why in the example. Often there is a lack of knowledge about the data being used, related to how the scope of the data, or where they're coming from, or the quality. But more importantly, sometimes there is really an inherent difficulty in interpreting how each of the many data points used by the machine learning algorithm contribute to the conclusion that we generated. That's a big problem. And to give an example, I think it's the black box problem, which represents what is lack of interpretability and lack of transparency. Sometimes we just do not have access to how an algorithm arrived to a certain conclusion. And to go back to our pros, if we need to justify or trigger an action based on the outcome, on the output of an algorithm, is that enough? Can we just trust the outcome without knowing what's behind it? Of course, I do not want to misrepresent also the issue here. Not many algorithms are, and not all of them are black box. Often, though, the difficulty is a different one as well. Let's imagine we can open the box. So a certain algorithm gives us access to its inner workings. We know in a peculiar kind or sense of knowing what the algorithm has done or how it worked, but we cannot make sense of it because it's just so complicated and it works in such a different way than the human mind. And that makes it difficult to understand, even though we have access to the explanation and even though that's transparent, how the algorithm got there. Okay, third one, we go back to our recipe. We have data, turn into evidence, give an outcome. Outcome used to trigger, motivate an action. Now we add a line, right? Action may not be ethically neutral. Okay, what about that? Well, that can happen with what we call misguided evidence. Let's think about the case of our detective here once again. Let's say um, he has the evidence he has received and the evidence he has collected, um, how, like, will be and might be in a way bias, right? He might have received or collected evidence from some citizens more than others. Some citizens were more accessible than others. He trusted some people more than others, maybe for also implicit bias consideration. We'll see what that is. And now the conclusion is nurtured by this evidence that he has collected. Will the conclusion um, be free from the bias he has collected along the way? To put this in the algorithmic context once again, so algorithms process data and are therefore subject to the limitations shared by all types of data processing. The informal principle, garbage in, garbage out, clearly illustrates what is at stake, which is that conclusions can only be as reliable, but also as neutral as the data they are based on. And I think there has been a lot of talk about it for good reasons. It's one of the main issues in terms of algorithmic fairness and algorithmic bias that might affect people's lives. One example, a concrete one, is the COMPASS algorithm. It's used in the US to calculate the likelihood of recidivism. Recidivism is so the likelihood of someone recommitting a crime in the criminal justice system. There was an investigation that I'm going to present in the case study at the end, which revealed that as the data on which the algorithm is based is biased against Black people, people of color, the algorithm generally outputs a higher risk score for this group than for white people. That's a clear case of bias. How do we deal with that? Open question. We're going to go in potential answers later on. Now I'm just going to like launch points of thoughts. We go back to our recipe. So data into evidence for a given outcome. Outcome is to trigger, motivate action. Action may not be ethically neutral. What can follow? Unfair outcomes. So that's an interesting one, I think, because, well, first let's put it back to the detective, okay? So the detective thinks, okay, now you see the detective has changed. He is white because, like, in the sense he's lit up. He has an idea. He thought he might have solved the case. He has an idea and he thinks that his suspects, the ones that he considered to be suspects, are actually culpable. And he's thinking how to deal with them. He has to pay attention that his judgment and also his proposed actions do not disproportionately harm his suspects. He's not even totally sure, right? We're still dealing with probability. Even though he has well founded knowledge, most probably, that his suspects and that his judgment is right. For example, testimonies from other villages lead to the outskirt area of the village, which they usually define as dodgy. The detective orders its team to start patrolling that area and interrogating other people in the area to get to the culprit. Even though the testimonies that lead towards the outskirt area and that lead to this intense patrolling are founded on a previous documented history of crime, is it okay for the detective to automatically link living conditions to culpability and thus to put all the citizens within that area just by virtue of living within that area as possible suspects? This might lead several people living there and might expose them to unnecessary stress, right? So these epistemic concerns, epistemic because they're totally linked to evidence that we have presented before, unfair outcomes, address the quality of the evidence and of the data produced by an algorithm to motivate a particular action. Now, this is different, unfair outcomes. Ethical evaluations of algorithms can also only focus on the action itself. An action can be found discriminatory, for example, solely from its effects on a protected class of people, even if made on the basis of conclusive, scrutable, and well founded evidence. In that sense, let's imagine that the villagers at a point and the history of crime was well documented and right in that area. We still ought to think about how our actions in dealing with the potential culprits or suspects in that areas affect the suspects and the whole population. An example of that to contextualize is maybe you thought I was going there, predictive policing. It is often based on determining individuals' threat levels by reference to commercial and social data. This can improperly link dark skin to higher risk or higher so-called threat levels. This can lead to more arrests for crimes in areas inhabited by people of color, but that's very much a social or economic issue that ties and suggests something about crime. That assumption might lead to unjustified actions that are unfair towards a group of people. Okay, now we are drawing to a close here, but I have still 2 points. I think we should finish all the concerns so that we can go into values and delve into them. So, algorithms work in complex and semi autonomous way. I see that there are some points in the chat. That's good. Still, in case you want to answer some of them, because then there will be the break, go for it. If you don't want to, we'll deal with them after the break. Okay, no problems. So algorithms work in complex and semi-autonomous way. First part of the prose. Um, we that part, which was actually the remember we had the prose, and it's like, oh yeah, turn that into evidence, evidence into action. But algorithms, there's an additional part at the end, work also in complex and autonomous ways. That adds a layer of complexity, right? And so also a layer of concerns. Now we talk about transformative effects. That sounds like a really general term, and I'm going to use the detective again. Imagine, since a while, the detective has been using a robot, and this robot is called Watson. You can see Watson, funny pun, or maybe not funny pun, on the right, to help him in his investigations. Watson is really smart. He remembers every person that they ever interrogate, and he creates a profile for each of them to aid the detective's work. Now, this generates questions. Is it okay that Watson stores all that information and that he profiles all of that pictures and that people? Can Watson aid or even semi determine, suggest culprits for the detective? Now, the ethical challenges posed by the spreading use of algorithms, or which is basically our detective, cannot always be retraced to clear cases of, evidence, as we saw before, or ethical failures, as we saw in unfair outcomes. For some of the effects of the reliance on algorithmic data processing or semi-autonomous decision making, as we just introduced, some of the reliance on those can be questionable and yet appear ethically neutral. Why? Because they do not seem to cause any obvious harm. Like, what is the harm if Watson profiles all the suspects? It's actually a matter of efficiency, right? It's going to help and aid the work of our detective. Um, However, and that's in that way, the practice of Watson storing all that info can also be problematic in other way and can be questionable in terms of maybe some of the values that we saw during and that appeared in the chat as a question, values of privacy, for example. Who is Watson? What power can Watson have in storing all that info? What can the detective do with all that info? How can it be accountable, but at the same time responsible with that info? But these concerns are something new, I think, because before the detectives were not aided by people like Watson. They just used their own head. An example is so algorithmic activities like profiling, which is our example, can lead to challenges for autonomy and also informational privacy. Big example, as we said, is profiling, which is the extensive collection of data which several companies conduct on their users. This practice is slowly transforming the way we understand privacy or the lack thereof, as our personal data becomes actually the fuel behind a company's product. Examples can be targeted advertising as well, nudging, or also political ads, which, thanks to the huge amount of data and semi-automatic and also semi-automatic way in which algorithms work, can incur in effects and in new effects that we were not concerned about before, and that we are yet to find even ethically questionable. So new ethical questions are arising, and that's what transformative effects deals with. Last one before the break. So algorithms work in complex and autonomous ways. That's a big one, traceability. Traceability, and here we see all the feed going around which leave traces. Let's say that our detective followed the lead and the advice of the robot Watson, which, thanks to his profiling activity, suggested to the detective the most likely culprit. The detective, happy and proud, presents his finding to the villagers and he puts the alleged culprit in prison. However, after that, several witnesses contradict his resolution, and in the end, it turns out that both the detective and the robot were wrong. The person who was put into prison was not a culprit. Who is responsible for this error in judgment? Was this Watson's error, so the robot, or the detective? And what went wrong in their reasoning and where? Was it in the profiling exercise? Was it in the thought of the detective? So this is related to the complexity. Algorithms are software artifacts. They are used in data processing, and as such, they also inherit the ethical challenges which are associated with the design and availability of new technologies, and also the concerns that are associated with the manipulation of large volumes of personal and other type of data. So this implies that harm caused by algorithmic activity is hard to debug, so to detect the harm and find its cause. And also it's rarely straightforward to identify who should be held responsible for the harm caused. One example is one that we saw before, a usual suspect, self-driving cars. It is hard to assign responsibility in that sense, right? It's a case in which the vehicle aims at replacing the human operator in driving autonomously. Self-driving cars raise important issues of responsibility in the case of car accidents where no human driver was behind the wheel. Here is all the panorama of the ethical concerns or problems we have raised. Now it's time for a break. Such a deserved break for all of us. I will put a timer. And Phil, I do not know, do you usually stop the recording during the break? Yes? Okay, perfect. I will stop the recording. 30 minutes from now, I started. And this is for you to guys take a break, get a coffee. Can I share my LI? What is my LI? I'm sorry if I don't know that. Oh, LinkedIn, perfect. Okay, Phil got it. No, no worries. That's it. Perfect. So okay, guys, I will be back to you. I think I need to sip a bit of coffee and a bit of water. Then I will be back. I think you need that as well. I ask you please to have a look at the timer because when we start, we're still halfway through the hardcore part. But I will need you to guess some of the ethical values that we use in reply to that concerns. So I need you to be rested for that. And the last part is hands-on about bias. We'll understand how bias can happen within an algorithm by going step by step. So yes, make sure to take a proper break. We'll be back. I'll stop the recording just for the moment.